Howdy, I'm Carson Roberts, and today I'll be talking about corn ethanol from field to fuel. Today I'm going to cover a little bit of background information and talk about how corn is collected and how ethanol is made from corn. Just some background information. Ethanol is an organic alcohol with the molecular formula C2H5OH. It is commonly used to synthesize other chemicals as a gasoline additive or as an alcoholic beverage intoxicant in humans. Now, collection of corn. Where do we get it? Corn is often planted in the late spring and then harvested in early summer or late fall. Fields are prepared by tilling, plowing, or no-till with pesticide application. The crop is then planted and awaits harvest. While we wait, the field must be maintained with pesticides and fertilizer, and then, once the crop has reached its harvest-ready mark, it is pulled out of the field by a combine. Now, once we have the corn kernels, what do? Well, those kernels are ground up and mixed with enzymes to be cooked at certain temperatures. Following yeast fermentation, the water is pulled out of the solution. In order to create gasoline, a molecular sieve is actually needed to be used to remove the rest of the water and completely dehydrate and then denature the alcohol to remove its drinkability. Now, let's talk logistics. What's the development behind this? Well, corn's actually been used for thousands of years to produce ethanol, but only recently has it expanded into fuel applications. But the carbon footprint is amazing. There's a 20 to 45% beneficial energy balance when using corn to produce ethanol comparative to other methods. Now, this being said, we also have to factor in environmental effects associated with corn planting, like soil erosion, pesticide runoff, local waterway contamination, and the exhaustion of soil nutrition. But we also have to consider that planting any type of crop will also have these environmental effects. Now, economic impact. Sources believe that corn ethanol production in the United States can actually increase without even having to change the resources that we already acquire. And this change would not damage or hurt other utilizations of corn or the crop trade demand. Now, has this been communicated to others? Well, it actually has. Due to recent gas price inflation, producers are actually supporting higher blends of ethanol in gasoline because the price is cheaper and it is better for the environment. I'm going to concentrate on my personal analysis of corn-based ethanol production. I decided to fully weigh the pros and cons and determine the financial ethicalness and the environmental impact. Monetarily, I concluded that an increase of corn ethanol production is positive because it lowers gas prices without damaging other markets. And the trends show an increase in overall yields and usage over the years, communicating that the process is positive. Now, the byproducts of the process are also redirected to be used elsewhere, creating further monetary activity and positive impact. Environmentally, it is obvious that an increase in corn ethanol production is positive to our world. And the efficiency is inconclusive. We really need more data on other crops to determine if this process is the best. However, in itself, it is efficient and it is reliable. Now the next steps. We need to research comparable crops to fill that void in our knowledge. And then we also need to conduct further research to ensure that this is the proper step that needs to be taken, or if there is another process that would be more beneficial. Now, what is the plan to increase this production? Well, first we have to research how we're going to do that. And then we got to create a higher demand by vouching for corn-produced ethanol production. We're going to do this by emphasizing economic and environmental impacts. And then we have to increase the number of processing plants to work towards this increased production efficiency, decreasing run cost, and keeping up with the demand. Once we've done that, all we have to do is monitor to ensure fluidity from the collection stage to the usage stage.